I'm just making a quick video doing a recap of lesson 3.2 for those of you who were absent or who maybe just wanted to see everything again. So we're working on that same standard, RPA1, and our learning target today is that I can identify proportional relationships from a table using a new term that we're calling the constant of proportionality. And we're also introducing a new variable in this lesson, and we're going to be looking at the variable k, which is going to represent this idea of the constant of proportionality. So going over some new vocab terms, well, we know ratio. Ratio is just comparing two quantities by division. But let's look at proportion. A proportion is an equation stating that two ratios are equal. So I have this example below that's saying we had 68 votes for Mr. Mears out of 100 people surveyed, and that is set equal to 34 votes for Mr. Mears out of 50 people surveyed. The reason that these are equal is because they share a multiplier. That is 68 times 1/2 is 34. And 100 times 1/2 is 50. We could also throw another ratio in here that is also in proportion. We could say, well, what about 34? Let's multiply that by 1/2 again. That will get us a numerator of 17. And we could take 50 and multiply that by 1/2 again. And that would get us a denominator of 25. So all three of these ratios are in proportion. And as we're moving through this unit, we're going to be talking about things in terms of their value. So the value is just a result of a calculation. And to use this same example of the proportion above, we could calculate each of these values. Let me change my color. So I could say the value of 17/25 is 17 divided by 25. You're welcome to use a calculator on these, but that is 0.68. I could calculate the value of 34/50 by saying 34 divided by 50, and that is also going to equal 0.68. I could calculate the value of 68 100ths by saying 68 divided by 100. That is also 0.68. So for this example, the value of each of these is 0.68. Now, in a proportion, this starts to take on meaning. Because if we look at the constant of proportionality, the definition of this is it's the value, k, of the ratio of two proportional quantities. So in our example, we have three proportional quantities, right? We had 68 over 100, 34 over 50, and 17 over 25. And the value of each of those was the same. So we could say here that k, or the value, equals 0.68. And when we're talking about the constant of proportionality, an important word there is constant. Constant meaning forever. Or someone in class said it goes on and on. So this idea of this k right here, this 0.68, being constant means that all numbers that are in this proportional relationship are going to have a k of 0.68. So every single ratio in this proportion will have a value or a k of 0.68. So let's see what that looks like in terms of the coffee industry. So I gave this example of these two places that I like to buy my coffee. One is Stumptown, and the other is the ISC coffee cart at school. And so we're given these tables, And what we have been doing is calculating a unit rate and that's just assuming that the unit rate is going to be the same for everything else on our table. And that's what you did in your homework. But now we're being asked to specifically find out if these relationships are proportional. So go ahead and pause this video and record these tables down in your journal, and then we'll get to work on them. Okay, so we're being asked, do both of these coffee shops sell their coffee at proportional rates? Why or why not? So I'm going to start my calculating. I'm going to start at Stumptown and look at this 3 cups of coffee. And I'm going to find my unit rate here. I'm going to say, well, $8.85 divided by 3 will tell me how much 1 cup of coffee is. And that equals $2.95. I'm just going to double check my work there. So 8.85 divided by 3. Yes, okay, I'm correct. All right, so now I need to see if it's the same for 5 cups of coffee. So I'll say 14.75 divided by 5. I'll go ahead and do that calculation. And it is indeed $2.95. So if these have the same K, if the value of 3 cups and 5 cups are the same, then this must be a proportional relationship, and we can go ahead and start calculating the rest of these. So 1 cup would be $2.95, and $2.95 over 1 is $2.95. And we could calculate 2 cups by saying, well, if 1 is $2.95, then 2 must be that times 2. And we'll have $5.90, and $5.90 divided by 2 is indeed $2.95. And then we can calculate that by taking that $2.95 and multiplying it by 4, and we'll end up with $11.80. And we can check it and say, well, $11.80 divided by 4, it is $2.95, so we're all good. So we're going to say that yes, this is proportional. And we'll do that same process for the ISC coffee cart. We'll say $4.50 divided by 3 is $1.50. And we'll check for 4. So what's 6 divided by 4? That is also $1.50. So these have the same K, so they are a proportion. So we can go ahead and start calculating the rest of them. We have 1 cup at $1.50. So $1.50 divided by 1 equals $1.50. We have 2 cups at $3. 3 divided by 2 is $1.50. And then you guys can go ahead and calculate 5 cups by saying 150 times 5. Oh, I'll just do it. So, okay, so that is $7.50. Just double check your work and make sure that $7.50 divided by 5 is indeed $1.50, which it is. So these all share the same K, so this is yes, proportional. Another important piece on these tables is that we want to decide what is our X and what is our Y value. And as a class, we agreed that X was cups and price was Y, because the price of your coffee depends on how many cups you buy. So X is cups and Y is price. And for all of these proportions, when we are calculating this K, for every single one, we were taking our Y value and dividing it by our X value. So in general, we can see that K equals Y divided by X. And so lastly here, we have Starbucks trying to compete with a local independent coffee shop by running a special pricing model. So I'm going to start calculating my k's here. In this case, we are given a full set of data, and all we need to do is decide if they're proportional. So I'm going to go ahead and start calculating. I know that 290 divided by 1 is just 290. And I can say 570 divided by 2. Do that calculation, and it is 285. I can do 840 divided by 3, and I'll come up with 280. I can say 11 divided by 4, and I'll come up with 275. I can say 1350 divided by 5, I'll come up with 270. And then I can say 1590 divided by 6, and I will come up with $2.65. So these all, while they do follow a pattern, they do not share the same value K. So these are not proportional. And the benefit of this pricing structure, and this is the kind of pricing structure a lot of places do actually use, is that it gets people to buy more because they think that the more things they buy, the better deal they get. So people to buy more. So again, we're going to calculate K by looking at Y divided by X. And if those K's are the same, they are proportional. If those K's are different, they are not proportional. So I'm going to say not proportional because they have different K's. Okay. So lastly, in a table, what are some ways we can determine if a relationship is or is not proportional? One way is we can calculate the value K. Another way, well, I'm just going to stop there for now because of this video, but we'll keep looking at other ways. So for now, just focus on, we'll calculate the value K. How is the constant and proportionality related to a unit rate? And what we found in class is that when a relationship is proportional, K equals the unit rate. And then what is a general equation we can use to calculate K in a proportional relationship? The big idea there is just to remember this very first formula of this unit, which is K will always equal Y divided by X. All right, I know I blasted through that. Feel free to email me if you have any lingering questions as you work on your homework. Thank you.